And we're live. Alright, so today we have ourselves an A1502. Jeez, that was loud. I'm just gonna mute that from now on. Yeah, YouTube's just telling me that we're live. So now we got ourselves today an A1502 that is just not powering on. And I realize this is super blurry, but I'm trying to mess around with our Logitech web camera here to get this a little bit closer so you guys can see what's going on. But it's not laggy, it's just there's a delay. Yeah, no, it's a delay. Okay, so what seems to be going on here is whenever we hook up our MagSafe to our computer here, once we hit our power supply, it is fluctuating between 0.01, 0.02, which tells me that it is missing something or something is pulling down, maybe some corrosion, but we are not getting all the necessary power rails for this to even turn on. So let's go ahead and just start by pulling out the main logic board and take a look to see if there's any obvious signs of damage to the inside of this computer. It is still summer, or I think it's still summer. We got liquid damage season, so the keyboard might be bad on the bottom side. We just don't know. So let's see what's going on. Okay, so yesterday was the first day of fall. No, I don't know anymore. It feels like it. Mm-hmm. And there's like some cereal or something inside of the computer. So the reason why I'm thinking this one is missing PM Sleep S4L is just because the amperage consumption is so low on the computer. Usually if it's anywhere between or below 0.02, that means that the computer's not sending all the right signals to start consuming more power to turn on. So PM Sleep S4L can go missing due to a couple of different things. Could be the SPI or the BIOS could be bad. The SMC could be bad. The CPU itself could actually be bad. Or the PCH, which is inside of the CPU on this model, could be bad. The clock could be bad. So this one is always an interesting one to troubleshoot. Do you mind checking on the status of the 11 Pro up there? Just to see if it's restoring? Sammy?
Me? Would you like to apply these changes?
Sammy, can you check on that? Okay. So that should be all the screws that are holding down the main logic board. So let's go ahead and pull this out. It looks like a toenail. Oh, that's exactly what that is. That was a toenail. And let's set the shell of the computer to the side. We just need to restore the computer. Or restore the phone. I'll be right back. Okay, and we're back. So now let's check to see if there's any obvious signs. And I can already see some corrosion right here with the naked eye. So now let's take a look at this underneath our microscope and see what that is. Alright, so yeah, we got a little bit of stuff around this diode right here. So that could be one of the reasons why this isn't turning on. So since we have corrosion there, let's check and see. Looks like this capacitor right here has got some corrosion. Alright, so that looks to be the only spot, those two spots in particular, that have corrosion. So this one is either a 2013 or a 2014. So let's go ahead and pull up our board view software.
Sure, what kind of phone do you have? Stylo 6. Okay.
And let's see, this one is a 3536, which is very similar to a 4924. So let's just open that one up. Oh wait, hold on. We actually had a 3536 right here. Okay, so this is the diode in question, the Q9700. What is Q9700 responsible for? That is a MOSFET, it looks like, that is responsible for HDMI Mux Select Thunderbolt. So this is probably pulling down 3 at the tool, which is putting the rest of the computer on. It's like garbage for. So let's go ahead and get our donor boards ready. And see, just because we're pressed for time, I'm just gonna go ahead and take a shortcut and see if we can fix the corrosion first without measuring power rails. Okay, and I have a donor board that has a good looking MOSFET. So for this one, let's go ahead and start pulling this off. So what this looks like is that maybe some liquid was spilled into the keyboard. Just a very, very tiny amount. This doesn't necessarily look like condensation buildup. And so it went through the keyboard, and this side of the logic board is directly underneath the keyboard, and had got specifically on this MOSFET. Or this diode specifically. I don't know, it looks like it's a diode that's being treated as a MOSFET. It's probably just a MOSFET. Yeah, it's a MOSFET. It's not a diode. And the consistency is which it's coming off almost looks like soup. And so this one's actually taken a while to come off, not only because of the corrosion, but I'm using my nozzle that I normally use for my iPhone, so the surface area around it is not heating up fast enough. Yeah, because see, it's wiggling a little bit, but right here, this is our ground connection, so this isn't moving like it should. So this isn't going to work. I actually need to just go ahead and switch out to our larger one. All right. Is Catalina what? So I've already removed that MOSFET here. And we just put a little bit more solder. So this is prepped and ready for our donor board. Now let's actually get our donor board out. And there is our component that we need. This one should come off a lot easier just because this board is not corroded like the other one is. Increase our air a little bit. Okay. Alright, the left solder pad is melted. I'm just waiting for this ground up here to move up some more. Alright, so now that we have our donor component, let's go ahead and pull it over. Alright. And I'm just going to heat it up a little bit more just to heat up the ground. And just for good measure, let's give it a little bit more flux. That looks good enough. So now that that is addressed, let's take a look at this capacitor that had a little bit of corrosion around it as well. That. I'm assuming that's a capacitor. Definitely looks bad. It almost looks cracked. And then let's find out if it is shorted. Yeah, so that is bad. And let's see exactly what that is. Let's see, so we are close to about right here. It looks like it might be this capacitor. Yep, that's this one, which is also part of our PP3V3. So it looks like PP3V3, S4, and SO were shorted, which was causing the computer to just not get the proper 3v3 signals to power on the clock and the rest of the computer. So let's go ahead and resolve this short. And for this, I'm going to end up using my hot tweezers. Just like that, just came right off. There's a lot of flux over on this donor board, but that capacitor looks like it's still there. Okay, it looks bad, but we're going to fix that. And let's see if we resolved our issue. So I'm going to check the resistance of this PP3V3S4 line, make sure that we are good. We have an infinite resistance, so I think we have resolved our issue. Let's go ahead and take a look and see if this is now going to turn on. So what we want to see on our power supply, and you'll just have to believe me because I don't have any fancy power supply reading software. Let's find out if this is actually going to turn on. Green light, our amperage is pulling 0.8. We got a fan spin. This is a working logic board. So that was successful. So let's take a look here and see exactly what was going on. And my method here was, instead of just checking the power rails, let's go ahead and do a visual inspection to cut down on some time. So if we look here on our schematic, right next to U9750, we had Q9700, which is a MOSFET. This is responsible for, it looks like it's a MUX that selects back and forth between our basically powers on the HDMI port. And being that it was damaged, it was sending PP3V3SO directly to ground, presumably. We didn't measure with our multimeter, we just replaced because it looked gross. PP3V3 is responsible for a lot of things on the computer, such as turning on the real-time clock, and I'm pretty sure that's also what powers the system management controller. Both of those devices are used for creating PM Sleep S4L. Well, that comes out of the CPU, but those components in particular, the clock, real-time clock, and the SMC, both have to have 3.3 volts in order for the computer to actually turn on. So if we're just going to assume that was shorted, since we were missing PM Sleep S4L and it was trying to turn on, but it looks like that was missing. And then on top of that, we also had corrosion. If we make our way all the way right here, C2952. C2952 is part of our PP3V3 S4 Thunderbolt. This is also connected to our Thunderbolt line, and this is the S4. So the S4 is going to be either hibernation or sleep. S5 is going to be if the computer is completely turned off but is receiving power. S4 is responsible for hibernation. presumably hibernation or sleep. I think sleep is going to be like S3, and then I don't know what S2 is, and S0 is going to be that the entire computer's turning on. So once again, our PP3v3, in this case, the S4 line was also shorted, and that we did confirm when we hooked up our multimeter to this part of pin 1 of C2952. So being that both PP3v3 S4 and SO were shorted on this line, that was preventing the entire computer from turning on. And now we could have gone through the process of checking power rails to confirm that PP3v3 was missing, but just for a matter of time, let's see, how long did this stream take? Only 20 minutes. We were able to efficiently fix this board. Now we are going to give it an ultrasonic cleaning just to make sure there's no more corrosion hiding anywhere else. This one also has a bad battery, so we're going to replace that too. So I'm going to go ahead and cut it here, but I hope that this has been informative, and I will see you guys in the next one. Bye.